Now, picking it up again for another installment of the Theater of the Mind by Professor Andy Molnar. So, we were saying that an administrator is someone who can make changes on a computer that will affect the other users of the computer. Administrators can change security settings and they can install software and hardware. They can access all the files on the computer and make changes to other user accounts. In addition to creating or changing user accounts, administrators, they're going to enable permissions, right? And permissions define who can get access to certain resources. For each user, the network administrator establishes a user account, and a user account enables the user to sign into or access resources on a network computer, right? So we load the username, which is a unique ID, and of course they would also load after that a private password. Now, we want to keep your password confidential. That's just a reminder. The OS on the network, it's going to record successful and unsuccessful sign-in attempts in a file. For those of you doing the Splunk log laboratory, you've already done that with a failed login attempt, and then you found that failed login attempt in the Splunk logging system. From a security perspective, if there are more than 3 failed login attempts, you're locked out. And I would want Splunk logging then to notify me if there were more than that. Because if somebody's trying multiple repeated attempts to log in and they get locked out, it's probably a password attack. And that's one of the signs of it. Now recall too that there are alternates to passwords that we've talked about in other lessons. There were passcodes, which are using numbers. Some of us do that on our phone. Or swiping is another way to do it. Biometrics is also considered a good way. And of course, passphrases. Passphrases are considered some of the strongest. Okay? So you might want to consider some of these aspects in your home network course project, end of course project. You, in that case, are the network administrator. Now here are OSs are proprietary. Here are 3 categories of operating systems and some of the names of the types of operating system you would find in that category. Proprietary software is privately owned and limited, and historically it has been proprietary. Now, the trend today is for device-independent OSs. So a device-independent operating system is the process of making that software application able to function on a wide variety of devices, regardless of the local hardware that you're using. Also, OSs are becoming backward compatible, right? Which means that the hardware or software, the system, it can easily interface with data or hardware and software from earlier versions or with other systems. So that's kind of nice. Okay, the desktop OS, sometimes called a standalone OS, is a complete operating system that works on desktops, laptops, and even some tablets. Now, the desktop OS is sometimes called a client operating system because they also work in conjunction with a server operating system, and that's really what a client is. A client can work with or without a network, but it's an association between the desktop and a server operating system. Now, Windows started in the mid-1990s, and it really came on stage with a graphical user interface, which was awesome. And these are some of the Windows features that you would find on their system. On this slide, you see some of the items that are highlighted in a Windows graphical user interface, Windows operating system. And so, I take a note. Most of them are fairly common to us, but some of them a little different. The ribbon, the status bar, maybe the start button, taskbar, notification, help button, and a quick access toolbar. Make note of those. Those are less commonly used. Most of the rest are fairly common to us. And to some of you, they will all be common. Now, for desktop operating systems, continued. Besides Windows, there's Apple's Macintosh OS. This really started back in the mid-'80s. And Apple has always had a reputation for ease of use. In fact, some would say that Windows stole the GUI concept from Apple. But that's beyond this course for sure. So Apple, it's a model for most GUIs. The Mac OS is the operating system that powers every single Mac, right? It lets you do things you simply can't do with other computers. And that's because it's really designed specifically for the hardware that it runs on. Now, Unix is another type of operating system. This was developed in the late 60s, maybe early 70s, and it has been under constant development ever since. So by operating system here, we really mean a suite of programs which makes the computer work, right? We've been talking about that. But Unix is extremely, for all the time it's been worked on, extremely stable. It's a multi-user, multitasking system for servers, desktops, and laptops. Some versions of Unix have a command line interface, but nowadays most Unix offer GUI interface. And power users, people that need a really highly capable OS, often work with Unix because of its flexibility and its capabilities. Now, Linux is source code that's available to the general public, whereas Unix is source code that is proprietary. Unix OS was, like I said, created in the late 60s, early 70s at AT&T Bell Labs, right? And this is, whereas Unix operating system was built by a guy named Linus Torvalds at the University of Helsinki in 1991. Now, some Linux is command line driven and some is GUI driven, like Unix. Now, Linux is an open source software, which means it is software for which the original source code is made freely available and made to be redistributed and modified according to the requirements, right? So open source software, this is software that by which the source code is usually available for modification or enhancement and reused and accessible by anyone. There are really no restrictions to copyright on open source software. Sometimes there are restrictions to redistribution, but usually not. I wouldn't worry about it much. But I'm not a lawyer. Consult a lawyer. I had to say that. Okay. Now, Chrome. Chrome is another type of operating system. It's a Linux kernel-based operating system designed by Google. It's derived from that free software Chrome OS and uses Google Chrome web browser as its principal user interface because it's going to be web focused. So it supports Chrome apps which resemble native applications as well as remote access to the desktop. Now, a specialized laptop that runs Chrome OS is called a Chromebook, right? And a specialized desktop that runs Chrome OS is called a Chromebox. Chromebooks and Chromeboxes typically use SSDs for their internal storage, and also know that Chrome OS can run on a virtual machine, which we'll discuss shortly. Now, because computers running on Chrome OS work mostly with web apps, they don't require much internal storage, really. So if you want to run multiple operating systems on the same computer, you would partition the hard drive. So, or you And so you could create this virtual machine. Now, partitioning, really what it's doing to the hard drive is it's dividing the hard drive into separate logical storage areas or partitions segregated from each other. And then you can install a separate OS in each partition. And you would do a dual boot, say if you had a couple of OSs on there. Now, a virtual machine, or VM, is an environment on a computer in which you can then install and run that OS and programs. And so VMs enable you to install, like I said, a second operating system. So a virtual machine is a computer file, typically called an image. It's an image, right, that behaves like the actual computer. You really only have one computer, but your hard drive has divided it now into partitioned it, separate systems. And it provides, so virtual hardware, including CPUs and memory, because it's using the same, frankly. It's an interesting concept. Now, oops, where'd I go here? There we go. A server OS is a multi-user OS. So this is about servers now, not desktops, not laptops anymore, not cell mobile machines. This is a server operating system. They're multi-user, and it organizes and coordinates how multiple users will get access to and share resources on a network. And remember, a client computer on a network is going to rely on servers for access to those resources. So server OSs are designed specifically to support all sizes of networks. They can handle high number of transactions, messaging, comms, and even backups. So many server OSs also support the virtualization we talked about. That's that practice of sharing or pooling computing resources that we just mentioned. Now, the OS on a mobile device is called a mobile OS, and it's going to reside in firmware, like on your phone. Recall that firmware consists of a ROM chip or flash memory chip that stores these permanent instructions. This is a slide on the Android operating system for mobile systems. More on that in your book. There's also a slide here on iOS, right, from Apple iOS, and some good literature there in your book. And of course, Windows has its own OS mobile edition that it can use. That pretty much wraps up operating systems and our time together this week. Don't forget the discussion board and the other things online that are due this week, and you should be wrapping up your course project and your reflective that goes with it. Thank you very much.